This is just going to be a quick video on temperature scales and temperature conversions. So there are three common temperature scales. The one that we use most in our everyday lives in the United States is, of course, the Fahrenheit scale. And then we have the Celsius scale and the Kelvin scale. For scientific work, it's the Celsius scale and the Kelvin scale that are the most widely used. Now, for the Celsius temperature scale, I think it's really important for any scientist to know how it's defined. Due to the importance of water in chemistry and biology and geology and really all of the sciences, the Celsius temperature scale is based on water. And so it's set so that water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. When we want to convert between Fahrenheit and Celsius, you can use either one of these equations. They're identical. 9/5 is 1.8. And you don't have to have these memorized. I'll give you the temperature conversions. You'll just have to know how to use them. I think it is a little bit helpful to have an idea of what some of the temperatures in the Celsius scale, how they compare to Fahrenheit temperature scales. So, of course, water freezes at 0 degrees Celsius. 10 degrees Celsius would be a brisk fall day. Room temperature is about 22 degrees Celsius. And a hot summer day in Death Valley would be about 40 degrees Celsius. So that kind of gives you an idea of how temperatures on the Celsius temperature scale compare to what we may be more familiar with in the Fahrenheit scale. Alright, so the Kelvin temperature scale is really important in science. It's what's called an absolute temperature scale. The reason we call it that is because the lowest possible temperature that can be achieved is negative 273 degrees Celsius, or that's negative 460 degrees Fahrenheit. It is impossible to have temperatures below that. And so that's what we call absolute zero. And in the Kelvin temperature scale, that's what's set to be 0. So what's useful about this is in the Kelvin temperature scale, temperatures cannot be negative. And so this helps us out a lot in calculations where having a negative temperature might give us weird results in the calculations. And so for many applications, we have to use the Kelvin temperature scale. Now, one interesting thing to note, the magnitude of a Kelvin is the same as the magnitude of a degree Celsius. So if we're talking temperature changes, a temperature change in Kelvin is going to be the same as it is in Celsius. So if we have a 25 degree temperature change in Celsius, we also have a 25 degree change in Kelvin. Now, just a note on nomenclature, we don't refer to kelvins as degrees. We don't say degrees Kelvin. We just say Kelvin. If the temperature is 298 Kelvin, we just say that. We don't say degrees. And we also don't use the degree symbol as we do in the Fahrenheit and Celsius scales. Also, if you note, when we talk about temperatures in Kelvin, we don't capitalize the K, although the symbol we use to represent Kelvin in terms of units is capital K. Now, because Celsius and Kelvin have the same magnitude, all we have to do to convert between the two is to just shift the temperature in Celsius by 273.15. Alright, so the last slide here, we'll just do a quick temperature conversion example. And so when we have meltdowns in nuclear power plants, what's happening is the reactor overheats and it actually gets hotter than the melting point of the nuclear fuel. And so the fuel starts to melt. The most common fuel used in reactors in the United States is uranium dioxide. So if the temperature of the core of the reactor gets above the melting point of uranium dioxide, we have a problem and a meltdown can occur. And so our problem, we're given the melting point of uranium dioxide in Fahrenheit, and we want to convert that temperature to Celsius and Kelvin. Now I'll give you the temperature conversions. So I would give you that a degree Fahrenheit is 9/5 of a degree Celsius plus 32. So we can use that to solve for the temperature in Celsius. Now, in a lot of applications, I like to rearrange my equation before I plug the numbers in. This is one example where I don't like to do that. Typically, when we have addition and subtraction, I think it's generally easier to go ahead and put in the values you're given and then do the algebra, rather than rearranging the equation first. But you can do it however you like. So I'm going to plug in the temperature in Fahrenheit. Alright, so the first thing we would want to do to solve for this is to subtract 32 from both sides. And so I get 5157 is equal to 9/5 C. And so then to finish solving for C, I need to multiply both sides by the reciprocal of 9/5. And so the temperature in Celsius is 2,865. Now to convert to Kelvin, we don't have an equation to go directly from Fahrenheit to Kelvin, and so I usually do this in 2 steps, but in this case, we already have the Celsius. If we weren't asked to calculate the Celsius, I would probably do that first, and then to get to Kelvin, we just need to take our temperature in Celsius and add 273.15. And so the temperature I get in Kelvin is 3,138 as our final answer.